All right, let's start with getting this thing set up. I'm gonna put our kind of basic form that we were working with all of Tuesday up on the top. That was our A. Whoa, chunky pen. Holy cow, try that again. A, 1 plus or minus r to the x. So, what pieces do we have here? What do we know? 500 is our starting amount. That's going to go in for our A here. So we're going to put our 500. Our 1 doesn't change. How about the plus or minus? Are we going to use plus or are we going to use minus?
Plus.
Let's say debate. I love it. I love debate. What do you think? Pays.
No, plus.
I was like, it's my savings account, so they paying me. So we're going to use a plus. That is the benefit of a savings account. They pay you interest. They give you a bonus for putting your money in the bank. So a savings account will pay you interest. So we put a plus. It's going to grow. Our savings accounts grow. What's going to go in for R? Yes, we're going to take this 3.2 and make it a decimal. That scooches it 1, 2 places. And it's 0.032. And what are we going to put in for our x? 8. That's going in for that time. So this is how we're setting it up. I'm going to simplify it one time before I put it in the calculator. But that's the way we evaluate these. 1 plus 0.032 is 1.032. Oop. Close it to the 8. And we're going to type that in the calculator. And I don't think I have my calculator open. And I don't know it's going to open on the right screen. Oh, it is going to open on the right screen. Huzzah. Huzzah, trying to open behind this. So we're going to have our 500 times 1.032 to the 8th. And we're just going to type it into the calculator like this. Boop. So if you put $500 in this bank account and leave it sit for 8 years, you get $643. That's a free $143.29. Thanks. We get $643.29. So they didn't put any more money in. Like, they put $500 in and walked away. Free money. Put your money in your bank account and let it sit. Let it simmer. Questions on this one? Okay. So what we're going to be working with today, it's not story problems, but it's using the pieces like this part. And we're going to be solving, trying to figure out some exponent pieces. It's one of those things that there's not a perfect place to put it in the chapter. So we kind of just are plopping it in here when we've started to work with them a little bit. And we'll go back to story problems tomorrow. But we're going to work with doing some solving and figuring out what our exponents are. So these are the first two we're going to look at here. And we're trying to figure out what x is. Whenever we say solving, that means my answer should say x equals blah, whatever it is. X equals blank. So I want to know what x is, or whatever our variable is. I think I mostly use x's because I was trying not to confuse us worse. So look at this first one here. I'm going to change my view to see what's it. So we have 2 to the x equals 2 to the third. So what does x equal? 3. When our bases are the same, we're looking at when the two exponents equal each other. Starting with a very, very simple one. It's not always going to be that simple. So if we look at this second one, 2 to the x minus 2 equals 3 to the 7th. What can we do? I want to know when this chunk is the same as this chunk. Since the bases are the same, what we can do is just set them equal to each other. I want to know when x minus 2 equals 7. 3 to the x minus 2 is going to be the same as 3 to the 7. So that means x minus 2 has to be the same as 7. So what are we going to do? Add 2. And we get that x is what? 9. So we add 2, and we get that x is 9. I'm going to fix this line under solving because I did not like the way it was slanted. Oh, that's much better. That's much better. Okay. They will get worse, I promise. They're not going to be this 1 and 2 step things. But I wanted us to see where things were coming from before I started tossing weird things at you. I'm going to give you guys a second to write because I still see a lot of people writing, and that's okay. Oh, there we go. Now we stopped. Boop. All right, next two are slightly harder. So we've got 4 to the 2x minus 3 equaling 4 to the x plus 5. Yes, dear.
Are we able to bring it down like a regular equation and letting it like 2x minus 3 is equal to x plus 5?
That is 100% exactly what we're going to do. Yep. Since our bases are the same, they're not really doing anything. I just need to know when this chunk equals this chunk. Because 2x minus 3 needs to equal x plus 5 in order for these two statements to match. So what can we do to solve this and figure out what x is going to be? We're going to, sorry, say it again. I was changing colors. Add 3. That's an excellent start. It's going to give me that 2x equals x plus 8. Then what can we do? Subtract x. I want to get my x's on one side and my numbers on the other. So let's get all the x's together. So 2x minus x gives me just 1x equals 8. And if you want to, you can go back here and check this. 2 times 8 gives us 16. Minus 3 gives us 13. 8 plus 5 gives us 13. So they do, in fact, equal each other. No matter what this value is, as long as these exponents match, we're fine. We could only do this when our bases match. So when these 4s match. So now I'm throwing you another wrench over here on the right-hand one. We've got 3 to the x equals 27.
Good morning, pardon this interruption. The weighted testing continues. The morning group
So then I think you go today.
testing room. Thank you.
So look on the right-hand one. What do we notice about a base of 3 and 27?
Shelton, you know what to do too.
What do we know about 27? 3 cubed is 27. So I can rewrite this in order to have this base. So we can write this as 3 cubed, and this side is 3 to the x. So when we don't have bases that match, make them match. Every time, everyone I'm going to give you is going to have a way to make the bases match because we don't have the tools to do it when our bases don't match yet. Next chapter, we will be able to do it when the bases don't match. So on this one, what is our x? X equals what? 3. So we're going to do a few like that. So if I give you one, I'll leave it out bigger. If I give you one like this first one, where we have 3 to the x plus 1 equals 27, well, we just talked about 27 being 3 cubed. So this can be 3 cubed. And this side is 3 to the x plus 1. Once we have our bases that match, I can take my exponents and set them equal to each other. I want to know, when does x plus 1 equal 3? When does x plus 1 equal 3? When x equals what? 2. And that's our answer. X equals 2. The next one's a little bit harder. Because we've got 2 to the 2x equals 8 squared. Bless you. So what common base can they have? We look at 2 and 8. Can I rate 8 in terms of 2's? What is 8 written with a base of 2? 2 to the what? Cubed. So 8 turns into 2 cubed. I still have it being squared. And my left-hand side is still the same. So I'm just going to bring everything down right there. 2 to the 2x. So my 8 turns into 2 cubed. What are we going to do with these two exponents? Multiply them. So this becomes 2 to the 2x equals 2 to the 6th. We multiply. Now we have our bases that match. Everybody's outside parentheses, and we can look at our exponents. Because we want to know, when does 2x equal 6? You got to have the bases matching in order to set your exponents equal. So what's our solution here? X equals what? 3. I'm hitting 3 a lot. Apparently I was in a 3 mood when I wrote this slideshow. Because we're getting 3 lots. I think I was just trying to not give you gargantuan numbers. Okay, I'm feeling. Got 2 more. These are going to be doozies. All right. So here's our next one. I'll zoom it in so you can see it because I feel like it's a little small. 4 to the 5x plus 1 and 64 to the 7th. Bless you. So they don't have the same base right now. So we need to make them have the same base. What can we do? 64 we can write as 4 cubed. This one's already in base 4, so that'll work just perfectly for us. Because now we have 4 cubed to the 7th and 4 to the 5x plus 1. 64 is 4 cubed. So then we need to simplify this piece. That's not the laser pointer. This piece. What are we going to do with these two numbers? Multiply. Power of a power, we multiply them. So when I take 4 cubed and raise it to the 7th, we multiply the 3 and the 7. So we're going to have 4 to the 5x plus 1 equals 4 to the 3 times 7. 3 times 7 is 21. Once our bases match, we can look at our exponents. 5x plus 1 and 21. So we want to know, when does 5x plus 1 equal 21? It does. So we're going to subtract 1 from both sides to get our 5x equals 20. So what does x equal? 4. So make your bases match. Oftentimes it will be the smaller of the two, but not always. And we're going to see one like that here in a second. So make your bases match, then set your exponents equal to each other. We have one more to do. And it's probably the weirdest one. Because we have 1/2 to the 4x minus 16 equals 16 to the 2x minus 5. What base can they both have? Got 1/2 and 16. What does it take to make something a fraction using an exponent? Remember? A negative. So I could rewrite 1/2 as 2 to the minus 1. So how can I rewrite 16? Can I make it have this base? 2 to the what? To the 4. Because all I need is 2 to the what is 16. So change both of our bases to have the same base. Oh, I have parentheses. So my 16 turns into 2 to the 4th, and it still keeps its 2x minus 5. 1/2 becomes 2 to the minus 1, and it keeps its 4x minus 16. So sometimes you will have to change both bases, but that's a rarity. More often than not, we are only changing one, like the ones we've done before. So then, just like before, we're going to take our exponents and we're going to multiply them. I'm going to do this one in a couple of steps because there's a lot of pieces here. So we're going to have 2 to the negative 1 times 4x minus 16. And 2 to the 4 times 2x minus 5. Because we need to make sure that we're going to distribute it. I'm going to zoom this back out so you don't have to follow my brain. So we're going to need to distribute these. We can set them equal to each other first so we don't have to work in the tiny space. Now that our bases match, we can set these pieces equal to each other. Minus 1 times 4x minus 16 equals 4 times 2x minus 5. Once we have our bases that match, I'm going to change this so I have more space. There we go. Once we have our bases that match, we can take them out of the exponent and set them equal. Now what do we need to do in order to solve these on the orange line? Distribute. I got to distribute my minus 1 to get minus 4x plus 16. And we're going to distribute the 4 to get 8x minus 20. What are we going to do next? Lots of choices here. Add 20. It's going to give me minus 4x plus 36 equals 8x. Then what? I was going to say, I would recommend getting your x's together first, and just so that then we don't have to divide more than we need to. So let's add 4x to gather our x's together. 36 equals 12x. Now what are we going to do? By 12. So we get x equals our favorite answer of the day. I swear. Like half of our answers had x equals 3. What kind of mood was I in? Okay. It happens. It happens. Okay, so your whole goal with these is to make your bases be the same so that you can get them out of the exponents anyway, because the exponent part is kind of gross. So the whole goal is to make your bases match so we can play with the exponents on their own. I'm going to pass out the 7.2 worksheet. You guys are going to have the rest of the day to work on that. It also, again, has problems for tomorrow because I never give you a worksheet for just one day because that's doing too much. So if you did not do it, you can also do the 2-7 on Alex. That's what we had for yesterday when I was out. You should still be able to get into that. We are going to be doing a skills check on the e-learning day next week. And then our chapter test is on the 23rd. So it's kind of the vibe. All right, I'm going to pass out the 7.2. You guys can work on stuff, ask questions, all that jazz. And I'm 95% sure I printed out 7.2. Ha! Look at me organizing myself. All right, so really there's only 3 on here that are using these solving. It's the first 3, but it takes a little bit of time when we're getting used to it. And And then you guys can also do the review questions on the back.
Yeah.
But, the second question, number one, I love that. There's two questions for once. It restarted its own counting. The second question, number one, is what we're gonna do tomorrow.